Artificial intelligence, machine learning, and deep learning are often used as if they mean exactly the same thing. They don't. They are closely related, but each term describes a different level of the same technology family. In the next few minutes, you'll see exactly how they fit together. By the end, you'll be able to classify almost any so-called AI product without memorizing a textbook definition. The easiest way to understand the relationship is to picture three circles nested inside one another. Artificial intelligence is the largest circle. Machine learning sits inside artificial intelligence. Deep learning sits inside machine learning. Each inner circle is a more specific way of achieving the goal described by the circle around it. Keep this picture in mind because everything else in this lesson builds on it. Start with the largest circle, artificial intelligence. AI is the broad goal of making computers perform tasks that appear to require human intelligence. The phrase describes a capability we want from a system, not one single technique. An AI system may recognize an object, understand a command, plan a route, recommend a video, or choose a move in a strategy game. That broad definition matters because an AI system does not always have to learn from data. A route planner might combine search algorithms with carefully designed rules. A game character might follow rules about when to hide, attack, or retreat. These systems can produce useful, apparently intelligent behavior, even if nobody trains a model on thousands of examples. Imagine an older chess program built from rules and search. Expert knowledge tells the program how valuable different pieces are, which positions are dangerous, and how to evaluate possible moves. The computer explores many branches and selects the move with the best score. It may play impressive chess, but the central behavior comes from programmed logic and search rather than learning patterns from a training dataset. That still belongs under the AI umbrella. Inside artificial intelligence sits machine learning. Machine learning is one way to create intelligent behavior. Instead of writing every possible rule yourself, you give the system examples and let an algorithm find useful patterns. The result is a model, a mathematical structure adjusted by experience, so it can make a prediction or decision when it sees new information. Suppose you want to filter spam email. A fixed rule might say, if a message contains the words "claim your prize," mark it as spam. But spammers change their wording, and legitimate messages can mention prizes too. You could keep adding rules forever, yet language changes faster than your rulebook. This is exactly the kind of situation where learning from many examples becomes useful. With machine learning, we provide many past emails labeled spam or not spam. A learning algorithm studies patterns across those examples. Combinations of words, sender behavior, unusual links, formatting, and many other signals. It adjusts the model to reduce its mistakes. When a new message arrives, the model does not look for only one phrase. It combines the patterns it learned and estimates which label fits best. This does not mean the machine thinks like a person or understands an inbox the way you do. It means the system adjusts mathematical parameters so its predictions improve on the examples it receives. The quality of those examples matters. Biased, incomplete, outdated, or incorrectly labeled data can teach the model the wrong patterns. Machine learning is powerful, but it is not magic and it is never separate from its data. Machine learning is therefore a subset of artificial intelligence. A spam classifier that learns from examples is both machine learning and AI. A rule-based chess system may be AI without being machine learning. So every machine learning system used for an intelligent task belongs inside AI, but not every AI system learns from data. That single distinction clears up a large part of the confusion. Now move into the smallest circle, deep learning. Deep learning is a subset of machine learning built around neural networks with multiple processing layers. It still learns from data, so it is machine learning. And because it creates intelligent behavior, it is also artificial intelligence. What makes it special is the layered neural network structure used to discover increasingly useful representations. A neural network contains connected units that transform information. Each unit receives values, applies a simple calculation, and passes a result forward. One unit is not very impressive, but large groups of units arranged in layers can represent complicated patterns. During training, the network changes the strength of its connections so that the final output moves closer to the correct answer. Repeated across many examples, those small corrections become a useful model. Consider an image recognition system. Early layers may react to simple edges, colors, or directions. Later layers combine edges into shapes and textures. Deeper layers combine those shapes into features such as eyes, ears, wheels, or windows. The final layers use those features to estimate what the complete image contains. The network learns these internal representations from data instead of requiring a programmer to describe every possible visual pattern by hand. The word deep refers to the number of processing layers, not to the system having deep thoughts or consciousness. Deep learning became especially useful for complex, unstructured information such as images, audio, and language. It powers many modern speech recognition systems, image generators, and large language models. But the name tells you about the architecture, not whether the system truly understands a world like a human being. Deep learning is also not automatically the best choice for every problem. A smaller machine learning model can be faster, cheaper, easier to explain, and more accurate when you have limited structured data. If a simple model solves the task reliably, using a giant neural network may only add cost and complexity. Good engineering means choosing the simplest method that meets the real requirement, not automatically choosing the most fashionable one. Consider a phone that unlocks when it recognizes its owner. The overall ability, recognizing a face to make an intelligent decision, is artificial intelligence. Learning visual patterns from many training examples is machine learning. If the recognition model uses a neural network with many layers, the specific method is deep learning. It is the same product described at 3 levels: the broad capability, the learning approach, and the particular layered technique. Here is another way to remember it. Think of transportation as the broad system containing roads, trains, boats, aircraft, bicycles, and many other ways to move. Motor vehicles are one category inside transportation. Electric cars are a more specific category inside motor vehicles. In this analogy, AI is transportation, machine learning is motor vehicles, and deep learning is electric cars. Each inner group belongs to the group around it, but the names are not interchangeable. When someone says a product uses AI, ask 2 questions. First, does the system mainly follow manually designed rules, or does it learn patterns from data? If it learns from examples, it uses machine learning. Second, does that learning method use a neural network with multiple layers? If yes, it uses deep learning. Remember the final summary. AI is the broad goal. Machine learning learns patterns from data, and deep learning does that layer neural networks. In the next lesson, we'll open the middle circle and see how a machine actually learns from examples, without big mathematics. Subscribe if you want AI to make sense one step at a time.